Today I'll be explaining linear congruential generator or LCG, which is a simple and widely used method for generating pseudo-random numbers. So random numbers play a very important role in areas like cryptography, statistical analysis, simulation, and gaming. However, computers cannot generate truly random numbers, so we use algorithms like LCG to produce sequences that appear random. The general formula of LCG is x of n plus 1 is equal to a xn plus c of mod n. So where xn is the current number, a is the multiplier, c is the increment, m is the modulus, x0 is the seed or starting value. The quality of random numbers depend heavily on choice of these parameters. So our main goals are to generate pseudo-random sequences, to analyze the period of generator, to find parameters that give a full period, to test randomness using statistical methods. Here we will explain how the LCG algorithm works, then implement using a programming language, generate sequences of pseudo-random numbers, then analyze the period of sequence, which tells us when the number starts repeating, and evaluate the quality of randomness using basic tests. So through this demonstration, we aim to show both the strengths and limitations of LCG and why parameter selection plays a crucial role in achieving good randomness. So now let's move on to understanding the concept.
The linear congruential generator based on a formula of x of n plus 1 is equal to axn plus c mod m. What is LCG? The LCG is the oldest and the simplest algorithm for generating a sequence of pseudo random numbers, and and the formula is a is a multiplier, c is an incrementer, and m is a modulus, and x0 is a seed. Here we will applying the formula. X is x1. After we getting the answer of x1, we will be applying this answer to the xn. The same way it rotates. Then the quality of the random number depends heavily on the choice of these parameters. The key concept here is the period, which means how long the sequence rows before repeating itself. A good LCG should have a full period, meaning it generates all possible value before repeating.
So in this program, we implement the linear congruential generator using the function LCG. Here a is the multiplier, c is the increment, and m is the modulus. Seed is considered as the initial starting value. Then we use for loop for generating random numbers, and inside the loop we apply the LCG formula, which is x equal to ax plus c mod of m. The period of an LCG is the number of values generated before the sequence starts. A good LCG should have a full period, meaning it generates all possible values before repeating. The maximum possible period is equal to m. For full period, the following conditions must be satisfied. C and m must be co-prime. A minus 1 must be divisible by all prime factors of m. If m is divisible, we tested different parameter values and observed some parameters give short cycles, some give full period. We calculated the period by tracking generated numbers, detecting when a value repeats. For our experiments, we found that given standard parameters produce near full period sequences. Now, let's evaluate randomness using statistical tests. So, for test case 1, we have taken the values a1 equal to 1664525 and C1 is equal to 1013904223. M1 is equal to 2 power of 32 and C1 is 10. For sequence 1 equal to LCG of A1, C1, M1, C1, comma 10, then it will print the generated numbers of sequence 1. For test case 2, we have taken A2 is equal to 110351525, C2 is equal to 12345, M2 is equal to 2 power of 31, C2 is equal to 10, and sequence 2 will be equal to LCG of A2, C2, M2, C2, 10, and it will print the generated numbers. Here, in test case 1, we use values commonly used in practice, and in test case 2, we use another standard set. Finally, we print the generated sequence and observe how the numbers change. This is the solution for test case 1 and this is for test case 2. These are the generated numbers.
Okay, now let us see the randomness testing. To check the quality of generated numbers, we perform statistical tests. There are two main tests. One is frequency test, another one is run test. Frequency test, it checks whether numbers are evenly distributed. Here we can see whether the numbers are evenly distributed or not. And a good generator should produce uniform distribution. Now run test. It checks the randomness in the sequence order and ensures numbers are not following. Okay, our observation in this output are: good parameter choices passed both test and reasonably well. Poor parameter choices showed patterns and failed tests. So let us move to the conclusion part. In this project, we learned that LCG is simple but sensitive to parameter selection. Proper parameter produce long periods and better randomness. Statistical tests are essential to evaluate and performance. Okay, some of the applications of LCG are simulators, gaming, and cryptography. That's all. Thank you.